And range. If you're going to continue on with mathematics, you're going to have to get this whole function notation down. Okay. From this point on, you'll be using function notation. If you're going to go on in mathematics, that's all you're going to use. It's a lot easier to use function notation instead of using, and also it is we're using the f of x. I gotta find my pen. We're using the f of x instead of y. That's function notation. Now, we use this because I'm going to zoom in. Geez, my mouse is touchy. Okay, we use this because it's a lot easier to evaluate when we have a value for x. Instead of saying, well, evaluate this equation when y equals -5 or whatever it is. It's just easier to put in, hey, find the f of 5. The input value is going to be what the x equals. In this case, our input value is, well, x equals 5. Oops. And the output, well, we have to figure that out. So we're going to have to look at the f of 5, and we're going to have to substitute in 5 for the x. So 3, I'm going to substitute in 5 for the x plus 4. Because function notation says, hey, my x is 5. I'm going to substitute it in. So 3 times 5 is 15 plus 4. So my y, remember that's just notation for y, or the output value is 19. Okay, a little vocabulary when we're dealing with functions, domain, and range. A relation is any set of ordered pairs. Ordered pairs. Okay. Our domain is going to be all of our x values. Now, we have different names for x values. Um, Mathematically, we use either x values, domain, or input. Your science courses like to call these the independent variable. Okay. Science courses always, well, they really like that independent variable vocabulary. The range, the range is going to be all of the y values. And sometimes in mathematics, we like to call these output values. Your science courses, dependent variable. Okay. Just like we did up here. Okay. Now, we chose the input 5. Okay. We chose 5 for the x. So that was our independent variable because we chose that. Then we had to substitute in our x, our 5 for x, and solve to get our y. That's our range. That's why we call these dependent variables. It was all dependent on that 5 that we chose. Does that make sense? Why we call these independent and dependent variables? These are used more in life than x values or domain and range. Okay? Real life problems in real life careers and in your real life jobs, you're going to call these independent and dependent variables. Okay? And a function, definition of a function, for every x value, there is exactly one y value. Now, this gets really confusing. Okay? This definition gets confusing, and we're going to do some examples on that. In fact, we're going to do an example right now. Okay, they give us a chart here. Now, back in the day, we used to call these T charts, and actually, I had a student last hour said, "Hey, we still call these T charts, okay, because it kind of represents a T if you don't make a chart out of it, use the sides." All right, so every one of these ordered pairs, 2 comma 4, is a relation, okay? 2 comma 4, negative 1 comma 3. What else do we have? We have 2 comma 6, and then we have 0 comma 2, right? So this is a set of ordered pairs. That's why this is called a relation. Well, I'm going to go ahead and graph these ordered pairs. I have 2 comma 4, 2 comma 4. I have negative 1 comma 3, 2 comma 6, and 0 comma 2. Now, I'm not going to draw a line between these because all they gave me was the ordered pairs. So there's a graph of my ordered pairs. Now I have to determine the domain and the range and whether it's a function or not. Yes, Spencer.
You said zero. You said 0, 2. That looks more like 0, 0.
Oh, that is 0, 0. It should be 0, 2. Sorry. Thank you. Okay. Yeah, I need to wipe that out. Okay. Now, using the definition at this point, because that's all I taught you, right? Is this a function? Is there exactly one y value for every x? Yes?
Yes.
No? Yes? No? Yes? I see a couple of yeses, and I hear one no. Anybody say, anybody agree with Caden over there? So just Caden's awful, just by himself there? Just, I hate to tell you this. This is not a function. Okay? Not a function. Because, look at this. I have an x value 2 that has a y value 4. I have an x value 2 that has a y value 6. So for every x, there is not exactly one y value in this set of ordered pairs. We have 2 y values for that too. This is really a hard concept to understand. Okay. So this is not a function because there's 2 y values for the one x value 2. For the x value 2, we have a 4 and a 6.
So if it was like 3, 6, it would be a function.
Yeah, if we had like a 3 there, that would be it would be a function. And that's really my next point here. Okay. Now, sometimes these T charts, sometimes the T charts, they go horizontal. Okay. They'll put the T going horizontal. They'll put the X up here and the Y. So here's my X. I have a 2. I have a -1. I have a 2. And I have a 0. For my Ys, I have a 4, a 3, a 6, and a 2. Now you saw how difficult it is using the definition to determine whether something's a function or not, right? There is an easier way to do this. In fact, there's a couple of easier ways to do this. If I look at my x's here, and I could either use this or this, I have the same value, right? The 2 is twice. 99% of the time, if I have the same x value, chances are it's not going to be a function. All I have to do is look down here, and if there's 2 different values for that 2, it's not a function. Yeah.
Does this also mean that negative numbers, if there's a negative 2 and a negative or regular 2, does that mean that it's not a function or will it still be a function?
If this was a -2 here, it would be a function,
Gotcha.
okay, because it's a different x value.
Okay. Thank you.
Okay. So this, I hate, I hate shortcuts, but this is a really pretty good shortcut. If you see the same x value, chances are it's not going to be a function. Just check those y values or those outputs. All right, let's do another one. Oh, the domain. Got to do the domains. So my domain here, it's just a set of the coordinate, the x coordinate of my points. So I like to put them in from smallest to largest. My smallest one is -1. Then I have a 0. Then I have 2. And I don't need to put 2 twice. I only need to put it 1. Now, this is just a set of coordinate points, the coordinate value x of the point, because there's no line there. So I don't have to include all those numbers in between. The range are going to be the set of the y coordinates. And again, I'm going to put them in numerical order. If you don't worry about it. I'm not going to count it wrong. It's just proper to put it from least to biggest. Smallest one is 2. Then I have a 3. Then I have a 4. Then I have a 6. Okay. Questions? All right, let's do another example then. There's my T chart. And I'm going to go ahead and plot these points because this is a relation. It's a set of ordered pairs. The first ordered pair, 3, comma 4, -3, comma 3, 2, comma 4, and then 0, comma 5. Is this a function?
No.
Yeah,
I got a no.
Yeah.
I got a yes. I got a bunch of yeses now.
function.
Do I have a same x value here? No. So this is going to be a function because I don't have a double x value. So this is going to be a function. And because I have all different x coordinates here, that means I have there is exactly one value, one output, one y value, I should say, for every x. Now, I know what tricked some of you up a little bit was that I had a same y value for different x's. That's okay. Okay? I can have the same y value as long as I don't have the same x value. See how confusing this can get? There is yet an easier way to do this. But let's look at the domain and range first. My domain is going to be a set of points or x coordinates. Three, well, I'm going to put the smallest one in there. -3, 0, 2, and +3. And my range, see, my small one is 3, and then I got a 4, and I got a 5. Now I had the 4 twice, so I'm only going to put it in there once. And again, using that definition, and even though there's a little bit of a shortcut here, it's still a very difficult thing to determine if it's a function or not, right? Yes.
Why don't we use parentheses instead of that weird?
Good question. Good question. I'm using a set because I have exact values here for for my x, right? If I had a line connecting all of these, then I would have to include all of these values in here. Like I would have to include, -2, -1, and even the fractions in between all of those, which is going to be infinitely many, right? Then I would have to include those numbers, and that's where I get into my interval notation. And we're going to do that with some practice problems. So if there were lines in between here, I would have to consider those. So it would be, let's say I'm including the -3, and then it's going to go out to +3. So by using the interval notation, I'm including all of those points in between -3 and 3. Okay. These just happen to be just the points. That's why I'm using 3, -3, 2, and 0. Okay. All right. Like I said, there is, when you have a graph and you graph the points, or if there was a line there, it'd be graphable line, right? We do have something that's called the vertical line test. Now, how this works is you take a vertical line. I'm using a small little compass, and you start sliding it through your graph. Okay. If it intersects at more than one point, it is not a function. Here it intersects at one point. Here it intersects at one point. Here it intersects at one point. Here intersects at one point. So this is a function because it just passed my vertical line test. If I did it up here, intersects at one point, intersects at one point, but now it intersects at 2 points, therefore it is not a function. Right? Everyone see that? Okay. That's called the vertical line test, VLT for short. This is going to be the easiest, but unfortunately, it only works when you have a graph. All right, ready for some practice problems? Now, Galena, this is where we have graphs of lines. Now we're going to have to use interval notation and not just a set of coordinates. Okay? All right, so the first thing that I like to do is determine whether it's a function or not. So I'm going to use my vertical line test. And I'm going to go through here, and it intersects only at one point throughout my vertical line test. So this is indeed a function. So yes, it passes the vertical line test. So now I'm going to go back and pick up the domain and range. The domain is going to be, I'm just looking at my x axis. So it starts here, there's a closed circle here. It starts here at -6. And I'm just looking at my x axis, and it's going to stop here at +6. So I'm going to have an interval here because it's a line. It's going to start at -6, includes -6 because of that closed circle. And then it's going to go up here to +6, includes +6 because of that closed circle. Just looking at the x values. Next, I'm going to look at the y values. Well, my least y value, and I got to look at my graph, my least y value is going to be this one. So I'm going to find out here, it starts at -3. Includes the point -3 because of that closed circle. Then I'm going to look for the highest y value of my graph, which happens to be right here, which is 4. Includes that 0.4, so I'm going to use a bracket. So it's a function. My domain goes, my x values from -6 to +6. My range is going to go from -3 to +4. All right, number 4. I'm going to use my vertical line test. If it intersects at more than one point, then it is not a function. And this one, right off the bat here, it intersects at 2 points. So this is not a function. No, fails vertical line test. I still have to state what the domain and range is, though. So my domain, I'm looking only at the x axis. It looks like it starts here at -4. It's going to go up here to, looks like +8. And it's going to include those points. So I'm going to use brackets. My range, let's see, looks like it starts here at -4. Might be a little over, but I'm going to use -4. Includes -4. And then here, it looks like it goes over 1 a little bit. I'm going to say 1.5. So 1.5 and includes 1.5. If you put down 1, I'm not going to take off. And same with their homework sheet. I think there's some problems where they don't have any circles on there. So if you put parentheses or brackets, I'm not going to take off. Pardon me? Because I tell you the truth, this is probably because when we go to make the worksheets, we have to size it and try to fit it in there, and that's why it's off. If you, like I said, if you put 1 in there, I'm not going to take off. All right. Okay, number 5. Now, I didn't notice it right off the bat until I got to the range on this one, but this goes on forever and ever. Okay? You see the arrowheads? I didn't see them until halfway through the problem. So this goes on forever and ever. Okay. All right. Vertical line. Again, right off the bat, it intersects at more than one point. So this is not a function because it fails vertical line test. I still have to come up with the domain and range though. So I'm looking at just the x values for the domain. Now these are going to the left forever and ever and ever out to negative infinity, right? So I have negative infinity, always gets a parenthesis, but it does stop here. Let's see, it looks like 3. And I'm going to say it includes the point 3. Now I have to look at the y values. The smaller y value, well, this is going down to negative infinity, right? And it's actually going to go up to positive infinity. Always gets parentheses. And number 6, again, these are going up forever and ever because of the arrowheads. Is it a function? Yes. Only intersects at one point. So it is a function. Passes vertical line test. Domain. Again, this is going to the left forever and ever and ever. So it's going out. It starts at negative infinity. It's going to go out to positive infinity. We do have a starting point for the range. And please don't put 2. It actually starts here at 0, right? Y value 0. I'm going to say it includes 0, but it does go up to positive infinity. Questions, comments, concerns? Are you guys all domain, range, and function experts now? Wasn't that fun stuff? Yeah.